Okay, welcome everyone. We are doing lesson 6.5 today. Instead of looking at rational expressions where we have no equal sign today, we're actually going to be solving rational equations. So we're going to be having expressions with equal signs and then solving for different values of x that satisfy these. We are going to do the get started today, just to remind ourselves some strategies when we are doing algebra to solve equations. And then we'll get into the lesson. If you want to skip this part and you feel confident in your algebra skills, feel free to do so. Okay, so the first thing we need to remember when we're doing algebra is that what solve means. Solve, when you're given an equation, is find the values of x or whatever variable you have that satisfy this equation, that make this equation make sense. Find a value or values for the variable that make the equation true. Okay, so let's look at this first one here. We have 2x plus 2 equals 3x minus 4. We're trying to find what x is. Now, when you have an x on either side of the equation, what you want to do is move the x terms to one side of the equation, typically. So in this case, I'm going to subtract 2x from this side. You can also move the 3x to the left side, but this makes it positive, so I'll choose this way. So then I'll be left with 2 equals x minus 4. And now that you've got the x terms on one side, you just want to isolate the variable by doing opposite operations. So here I have a subtraction by 4, so I want to do the opposite of that, which is adding 4. And I have 6 equals x, or x equals 6. That's my final answer. And we should also mention that you can check this by plugging in 6 into the equation to make sure it works. I'm going to just do this once today, but just note on a test or quiz, you should always be verifying when you're solving equations because it's easy to make simple errors and you don't want that to be reflected in your final work. So you should always check and make sure you've got the right answer. So wherever there's an x in the equation, we're going to put a 6 because that's what we think the answer is. So put a 6 here. Minus 4. So this would be 12 plus 2, and this would be 18 minus 4. 12 plus 2 is 14. 18 minus 4 is also 14. Yeah, this equation checks out. It makes sense. Okay, for the second one, the strategy I want to remind you of here is if you have fractions, what you want to do is multiply both sides of the equation, so every single term in the equation, by something that's going to get rid of that fraction. It's just going to make your life a lot easier. So I'm going to multiply by 4 because 4 and 4 will cancel out here and I'll just have x. The 4 needs to be also multiplied with the 3 and with the 7. You need to do it to every term or else it'll change the equation. But if you do it to every term, you're keeping everything balanced, but you're making the equation a lot easier. And then we would simply just subtract 12 here. So this would be 16. Okay, and let's try the last one. Again, here you want to multiply by something that's going to get rid of the 3 and the 4. So I would multiply by 12. So 12 times n divided by 3 would be 4m. 12 times 3m divided by 4, that would be 6m, or sorry, 9m. And 13 times 12 is 156. 9m plus 4m is 13m. Put those together, and then we are multiplying here, so we do the opposite. We divide by 13, and that is 12. Okay, so that strategy is going to come up a lot in the equations we're going to solve below, where we are getting rid of the fractions first by multiplying. Okay, let's go to the first example. Check your solve each equation. Check your understanding number 1. I'm going to do both. I'll do 1a up above, and then we'll do 1a down below. So I'll rewrite 1a here. So 1 over 2x minus 2 over 5 equals 1 over 10x. Before you get started, you should write your non-permissible values, because if those show up as one of the answers in the end, we'll have to not use it. Because it would make the equation undefined. So for this one, the only non-permissible value is x cannot be 0. Okay, so first strategy here is we're going to multiply every single term on the left and the right by something that's going to cancel out all of those denominators, every single one. So a number that would 2, 5, and 10 would divide evenly into would be 10. So let's multiply every single term by 10. And let's also multiply every single term by x as well, because that's going to cancel out those x's. Okay, so let's see how that looks. So we'll have 10x over 2x. We'll have 20x over 5. I'm not canceling out just yet, just because I want to show how it works. And then on this side, I'll have 10x over 10x. Okay, so let's do our cancellations now. So this will be, these x's will cancel out. And the 10 divided by 2 would be 5. So this term is going to be 5. 20 divided by 5 is 4. And I'll have an x there. And this term will completely cancel out, so I'll just have 1. Look how much easier that equation looks now. Just by simply multiplying every term by 10x, I've changed it into something that looks challenging with a whole bunch of fractions into something that's pretty straightforward. Okay, so let's go ahead and solve this. This would be like a grade 8 level question now. I'm going to subtract 5 from both sides, so you're just isolating the variable to solve. And then we're dividing by 4. When you're doing these, try and keep your work nice and neat with the equal signs lined up and 1 equal sign per line. So you're showing each step per line here. And then you get x equals 1 as your final answer. You can verify that by plugging it in. I know also just by checking my answer down below that it is right. And 1 is not the non-permissible value, so we're all good here. Let's try the second one. So I have 5 over x plus 6 over x squared equals 6. So I'm going to multiply every single term here by something that's going to cancel out those fractions. I'm going to take x squared and multiply everything by x squared. So I have 5x squared over x, 6x squared over x squared, and 6x squared. Before I start 2, I should say x cannot be 0. That's my non-permissible value. Okay, let's do our cancellations. I'll be left with 1x on the top there. The x squareds completely cancel there. So I'll have 5x plus 6 equals 6x squared. So this is an equation that we've seen earlier in this course. This is a quadratic equation, so we need to solve it by factoring or completing the square. I'm going to solve this one by factoring. So I'll move all the terms to one side. So I'll have 6x squared minus 5x minus 6. And I'll skip the details on the factoring because we've reviewed that a lot. I'll just write how it factors. You guys can do that on your own. 3x plus 2, and then 2x minus 3. Just going to double check that that works. Yeah, that's good. So we have two solutions here. Either 3x plus 2 equals 0 or 2x minus 3 equals 0. So this one, subtract 2, we get 3x equals negative 2, which would mean x is negative 2 over 3. And this one, we add 3, so we get 2x equals 3, and then x equals 3 over 2. So we have two answers. So some questions in this section, you're going to have multiple answers, and some you'll just have one. So if you end up with a quadratic equation with an equation with an x squared in it, you want to solve it by factoring if you can. So move all the terms to one side and factor it to find your zeros. Okay, if you just have an x, just like we did in 1a, you just solve it by isolating that x. Okay, let's go to example number 2. I'm going to just do 2c for us. Okay, actually, no, I'll do 2a and then 2c. Let's do 2a up in the space above. So this is check your understanding number 2a. Okay, let me copy it down. So it'd be negative 3 over x plus 2. I like to put brackets around my factors just to remind myself that they kind of go together. 2x over x minus 3. So remember what we want to do. If we have fractions in our equation that we want to solve, we want to multiply by something that's going to cancel those out. So what I'm going to multiply by here is both factors that I see in the denominator, x plus 2 and x minus 3. That way both will be canceled out. So x plus 2, x minus 3. Okay. So on the left-hand side, the x plus 2 terms will cancel out. So I'll just simply be left with negative 3 times x minus 3. And then on the right-hand side, the x minus 3 terms will cancel out. So I'll be left with 2x, x plus 2. Okay. I should write my non-permissible values before I go too far ahead of myself. X cannot equal negative 2 or 3. We'll have to check that our answers aren't one of those non-permissible values in the end. Okay, so I'm going to expand this out now. I have negative 3x plus 9. And this one would be 2x squared plus 4x. This is a quadratic equation, so we need to solve by factoring if we can. Move all the terms to one side. So I'll have 2x squared plus 7x minus 9 equals 0. And that factors, I'll spare the details again on the factoring. If you need help with your factoring, let me know and I'll give you some resources. So it factors to 2x plus 9 and x minus 1. So there are two answers here. X equals 1 and x equals negative 9 over 2. Neither of these are the non-permissible values, so these are both solutions to the equation. Okay. Let's try to see, because we'll see something different happen here. Maybe we can try that. I'll use the space here, and I'll just write my work horizontally. First thing we want to do is factor. So I'll have 7x minus 15, and the denominator there factors to x minus 3, x plus 3. And this one will have x minus 2 over x minus 3. Okay. Non-permissible values, x cannot equal to 3 or negative 3. That would make the denominator 0. Okay, let's multiply now by something that's going to cancel out the denominators. And I need to multiply by the same thing on both sides. So I'm going to multiply by both factors that I see there, x plus 3 and x minus 3. On the left-hand side, those completely get canceled out. And on the right-hand side, just the x minus 3 gets canceled out. So on the left side, because everything in the denominator got canceled, I'll just have 7x minus 15. And on the right-hand side, I have x minus 2 times x plus 3. Okay. I will need to FOIL this out now. So I'll have 7x minus 15 equals x squared plus x minus 6. Oops. Again, this is a quadratic equation, which you'll see a lot in this section. So you'll have to solve by factoring if you can. I'm going to move everything to one side. So we'll have minus 6x minus 21. Not minus 21, sorry, plus 9. Negative 6 plus 15 is positive 9. Okay, now we can factor this. I'll move everything over here. This factors to x minus 3 times x minus 3. So there's two solutions, but they're both the same. 3 and 3. 3 actually, though, we have to really be careful. 3 was one of the non-permissible values. So neither of these can be the solution because they would make the original equation undefined. So there are no solutions to this problem. So we always have to write down our non-permissible values because if they end up being one of the solutions, then that solution doesn't count. So this question has no solutions. There are no x values that make this equation true. Okay, we're going to do one more question. This one's a little bit more involved, but the idea is, again, still the same. We're going to do check your understanding 3b. Now you can try check your understanding 3a if you like. I'll do 3b just because it's the most complicated one. So what we want to do here, I'm going to write this all out, but we're going to factor the denominator of the left-hand side. So x plus 1 over x plus 6. Then we have x minus 2 over x plus 4. Then we have 11x plus 32 over, and this factors to x plus 4, x plus 6. So we should write right away that our non-permissible values are x cannot equal negative 4 or negative 6. So if either of those shows up in the solution, we can't use it. Okay, so we want to multiply by something. Every single both sides get this, you want to multiply by x plus 4 and x plus 6. That way, all the denominators will be canceled out. So for this term, and I'm going to do this term too, so we'll write it like this, plus 4, x plus 6. Okay, so for the first term, this x plus 6's will cancel out, so I'll just be left with x plus 1, x plus 4. For the second term, the x plus 4's will be canceled, so I'll be left with x minus 2, x plus 6. You have to be really proficient with your polynomials here. For this one, they all get canceled out, so I'll just have 11x plus 32. Okay, that looks like a big equation, but we want to expand this out and collect like terms, and then we can solve it. Okay, so the first one, expand it out. So FOIL this out, you get x squared plus 5x plus 4. The second one, FOILed out, you get x squared plus 4x minus 12. And then on this side, you get this. We're going to collect like terms here, so the x squareds can go together. The x terms, we'll move the 11x to the other side as well. So we'll have 9x minus 11x, so that's negative 2x. And then finally, we will move this 32 over as well. So we'll have 4 minus 12, which is negative 8, minus 32, which is negative 40. And we solve by factoring. There's a common factor of 2. So I pull that out and factor this further to x minus 5, x plus 4. So there are two solutions, two possible solutions here, x equals 5 or x equals negative 4. And again, we always have to be careful in this chapter because our solutions might be non-permissible values. And yes, the negative 4 was a non-permissible value. So that one does not count. So even though there were two possible solutions, only the x equals 5 is the full solution. And again, you can plug that into the original equation and double check that it is right. Okay, so that's the basic idea. You want to multiply first, always start by factoring and then multiplying by any factors you see in the denominators to cancel them out, and then solve the equation like you normally would.